Normandy, summer of 1944. A German Panther tank pauses at the edge of open farmland. The commander rises halfway out of his hatch, binoculars pressed to his eyes. Ahead lies nearly 3 kilometers of rolling ground, broken only by hedgerows and a distant tree line. No movement. No flashes. No sound of shelling. It looks safe. He signals the driver to move. Less than a minute later, the battlefield changes. Bullets begin striking the earth at steep angles, cracking into helmets, packs, and exposed flesh. Infantry advancing alongside the tank collapse where they stand. The fire is not horizontal. It is falling from above, like rain made of metal. The commander slams his hatch shut. Now he can only see through narrow periscopes. The advance slows to a crawl. The formation bunches up. Fear spreads. He never sees the weapon attacking him. The gun is more than 2 miles away, hidden behind British lines. The men operating it cannot see him either. This was not luck. It was doctrine. The weapon was the Vickers .303 medium machine gun, and the British Army used it in a way no other force truly mastered during the Second World War. Every major army fielded machine guns. The Germans had the milligram 34 and milligram 42, terrifying weapons whose rate of fire sounded like ripping cloth. The Americans relied on Browning designs, rugged, dependable, and deadly. The Soviets emphasized massed automatic weapons for close combat. But Britain approached the machine gun differently. Instead of treating it primarily as a squad weapon, British planners turned it into something closer to artillery. Not metaphorically. Literally. The problem of open ground. The battlefield problem was simple and brutal. Infantry advancing across exposed terrain suffered heavy losses. Tank commanders needed to observe the battlefield to fight effectively, which meant opening hatches and exposing themselves. Direct-fire machine guns could suppress enemy positions, but they revealed their own location with every burst. Once spotted, they drew return fire, mortars, or artillery. Suppression worked, but only briefly. The British asked a different question. What if fire could arrive without being seen or heard in advance? What if bullets did not come from the horizon, but from empty sky? What if even terrain that looked safe, far beyond visible enemy positions, was still lethal? The answer was indirect machine gun fire. An unfashionable weapon. By 1939, the Vickers looked obsolete. It was water-cooled when most armies were switching to air-cooled guns. It fed from cloth belts when box magazines promised faster handling. It was heavy, painfully so. The gun alone weighed around 30 pounds. Filled with water, closer to 40. Add the tripod, spare barrel, condenser can, and ammunition, and a full Vickers team hauled nearly 100 pounds before firing a single round. German officers studying British equipment saw an antique. They were mistaken. The Vickers fired the standard .303 British cartridge at roughly 450 to 600 rounds per minute, with a muzzle velocity of about 2,440 feet per second. On paper, this was unimpressive. German and American machine guns matched or exceeded these figures. The difference appeared after sustained firing began. Endurance as a weapon. Air-cooled machine guns heat rapidly. Milligram 42 crews were trained to fire in short bursts and swap barrels frequently, sometimes after only a few hundred rounds. Spare barrels and asbestos gloves were essential. Each barrel change meant seconds of vulnerability. The Vickers did not play by those rules. Its water jacket held several liters of water. After sustained fire, the water would boil, but steam was captured through a hose and condensed back into liquid. With disciplined heat management and regular barrel changes, a Vickers could fire continuously for astonishing lengths of time. 10,000 rounds per hour was sustainable. Not briefly. 4 hours. Post-war trials famously ran Vickers guns for hundreds of thousands, sometimes millions, of rounds with minimal mechanical failure. Few weapons in military history have demonstrated that level of reliability. This endurance unlocked something no air-cooled gun could reliably deliver: planned, sustained indirect fire. Machine guns as artillery. British doctrine did not treat machine gun units as extensions of infantry squads. Instead, they were organized into dedicated machine gun battalions at divisional level. These units did not react to enemy contact. They executed fire plans. Using specialized tripods equipped with dial sights, Vickers crews could set precise elevation and traverse angles without seeing the target. Range tables, published in fine increments, provided data for distance, bullet drop, wind correction, air density, temperature, and even the shape of the beaten zone at different ranges. This was not guesswork. Crews trained in ballistic mathematics normally associated with artillerymen. They adjusted fire by tapping traversing gears in repeatable increments, walking bursts across grid squares rather than aiming at individual soldiers. Targets were coordinates, not silhouettes. With later boat-tailed ammunition, effective fire extended to approximately 4,500 yards, over 2.5 miles. The beaten zone. The key concept was the beaten zone, the elliptical area where a burst of bullets impacts the ground. At short range, trajectories were flat, producing long, narrow beaten zones. At medium range, the angle steepened, creating wider, denser impact patterns. At extreme ranges, slight variations in muzzle velocity spread bullets over longer distances again. Understanding these shapes allowed planners to layer fire. A single gun was not enough. Effective indirect fire required at least 4 Vickers, their beaten zones overlapping to ensure continuous coverage. With more guns, entire sectors could be sealed off. Movement became impossible, not because of explosions, but because any exposure invited plunging fire from unseen weapons. Organization and mobility. Between the mid-1930s and the outbreak of war, several British regiments were converted into machine gun battalions, including the Middlesex, Manchester, Cheshire, and Royal Northumberland Fusiliers. A typical battalion fielded between 36 and 48 Vickers guns, organized into companies of 12. Later formations integrated heavy mortars, creating combined fire units. These battalions operated at brigade or divisional level. Their guns traveled in universal carriers, allowing rapid repositioning. Once in place, they could deliver sustained fire missions lasting hours, coordinated with artillery schedules. This was not suppression. It was area denial. Combat applications. Imperial War Museum records show Vickers guns active in every major British campaign. At Tobruk in 1941, they supported defensive operations against Axis armor. In Italy, New Zealand units used indirect machine gun fire against German positions in mountainous terrain. During the Normandy campaign, Vickers battalions supported advances across exposed ground where traditional suppression was insufficient. One of the most striking applications came late in the war during Operation Veritable in February 1945. This offensive employed the so-called pepper pot method, an integrated fire plan combining artillery, mortars, tanks, anti-aircraft guns in ground rolls, and machine gun battalions. Hundreds of barrels fired simultaneously, creating continuous fire from multiple trajectories. The Vickers filled the space between mortar arcs and artillery shells, delivering uninterrupted streams of plunging bullets that prevented movement across entire sectors. Burma, the forgotten theatre. Perhaps the clearest picture of Vickers' effectiveness comes from Burma. During the battles of Kohima and Impal in 1944, the 2nd Battalion Manchester Regiment served as a divisional machine gun battalion. Officer Rex Kinclark compiled detailed reports based on infantry feedback, creating one of the most valuable primary sources on Vickers employment. In jungle terrain where visibility was limited and artillery support inconsistent, sustained machine gun fire proved decisive. Japanese units attempting infiltration or repositioning were caught by fire they could not locate or silence. At Alamein, similar weapons cut down German tank crews fleeing disabled vehicles across open desert, demonstrating that even when targets were visible, the same guns could switch roles seamlessly. Why others didn't copy it? Germany possessed the technical means. The milligram 34 and milligram 42, mounted on the Lafette tripod with optical sights, were capable of indirect fire. Some mechanisms even automated beaten zone sweeping. What Germany lacked was doctrine. German tactics centered on the machine gun as the heart of the infantry squad. Firepower was decentralized, optimized for close-range maneuver warfare. There was no institutional push to treat machine guns as divisional artillery. The United States fielded the water-cooled M1917 Browning, which demonstrated comparable endurance. But American doctrine favored mobility and responsiveness. The later M1919 air-cooled gun became standard despite its limitations under sustained fire. British doctrine made sustained, planned machine gun fire routine. Other armies viewed it as theoretical or situational. Myths and reality. One legend often repeated claims that 10 Vickers guns fired 1,000,000 rounds in 12 hours during the First World War. Modern scholarship has corrected this. Detailed analysis of war diaries and logistics shows the actual figure was closer to 100,000 rounds from 6 guns. Still extraordinary, but not mythical. The truth needs no exaggeration. What matters is that Britain built a system. The legacy. The Vickers remained in frontline British service into the 1960s, finally retiring after more than 50 years. Other nations kept it even longer. Reports place operational Vickers guns in conflicts well into the late 20th century. Few weapons can claim such longevity. The Germans built the fastest machine gun of the war. The Americans built the most mobile. The British built a doctrine. They transformed an Edwardian-era design into a tool of modern combined arms warfare. Not by making it lighter or faster, but by understanding how to use it differently. German tank commanders learned to fear open ground, not because they could see danger, but because they could not. Somewhere beyond the horizon, British crews were checking wind tables, adjusting dials, and firing on coordinates. The bullets would arrive silently, falling from the sky. That was British engineering. Not just a weapon, but a way of thinking.